Hello there my good YouTubers. Today I'm making a quick video to what we're going to do, or I'm going to take you along for the ride, and we're going to make a half-wave centre-fed dipole. There's not much components needed. Obviously you need wire. The wires I've not got on the desk. This is cheap plastic washing line. This is the washing line without steel wire in the centre. This is literally just like a nylon core with, you know, a plastic on the outside. So you've got strands of nylon in the inside and then plastics, you know, on the outside. Fairly robust. It's all we need. We're not building a huge antenna. This is a 60 metre, and obviously what I'm going to do is I'm going to cut this in half, so I've got 30 metres either side, which is going to support the wire, because I don't want to use the wire itself, the copper wire, the radiating as the actual support line. I want the wire to be supported. So this is what we're going to use with that. The next area is you're going to need enamelled copper wire, and I've got 18 SWG gauge, which is 1.25 millimeters copper wire, enamelled copper wire, which we're going to use to wind a 1-to-1 effective current balun, which is not really a balun, it's more of a choke than it is a balun, and the choke's going to be there to, you know, stop any kind of interference, common noise and so on and so forth coming down our coaxial line and into the back of our radio, which will improve the performance of the end-fed half-wave, centre-fed half-wave dipole. I'm going to place it into an aluminium box. Now a lot of people are, how can we put it, annoyed about the fact, or not annoyed, but they don't use aluminium boxes primarily because they believe that they could short out and you could get arcing between the RF choke or your coils, the terminals and so on, and the aluminium case. Well, that's true, which is one of the reasons why, as we're building it and as we've completed it, we're going to coat it in a service. This is a service. I mean, there's many different manufacturers. Electrolube do one. You know, there's multitude of. I can't think off the top of my head the other ones, but this is just the one that was available that I got hold of. No particular, you know, preference to this, but as I said, this here, it's effectively, it's a type of a conformancy coating, but it's effectively a high tensile lacquer, and you spray this on your toroids or your enamelled copper wire and all your terminals and the inside of the aluminium box, etc., this, that and the other, and it stops the arcing over. It provides the insulation required to stop arcing, shorting out, short circuits, this, that and the other, and also helps to stop corrosion as well. There's a lot of benefits of spraying the inside of your end-fed or centre-fed baluns, you know, ununs and you know, RF chokes, etc. In regards with this stuff, as I say, it's you know, if you're looking for a quality type antenna build that you want to last for a good long period of time, then it's a good idea to use something like this. Again, it adds extra, you know, longevity, and you know, it's just that extra touch of quality to your your antenna builds. Obviously I've got the drills here because this is aluminium. Obviously, as I say, it's I mean, it's easy to work with this aluminium. This box here is made by Hammond, and I believe it's 111 by 62 or 64, one of the two that way, by 27 high, or deep shall we say, which is just the perfect width for an SO239, the square type SO239s to go on there. You could also use the round ones, which are easier, but they seem to be incredibly expensive from the suppliers that I'm going for. It's cheaper to buy the SO239 square ones. Don't ask me why they're more expensive or cheaper. I don't know. As I say, you would have thought the round ones or whatever, there's less material on them, they would have been cheaper, but they're not. So inside the box I've placed a set of components, which is what we're going to need. First off, we're going to need this is called a lifting eye. These are usually screwed on top of, heavy equipment, motors, this, that and the other, and they're threaded in. So this is an M6. And sorry, no, it's an M8, and obviously you thread an M8 thread inside this, the cast block or whatever it is, and then you screw these into the cast block, and then you can lift the item, whatever it is. As I say, you mainly find them on large 3-phase industrial cased and finned motors, which is, these aren't too expensive. They're about £1.30. You can buy these. This one's a stainless steel. Obviously this is going to be placed at the top of the box, which is going to be the hanger and the support for the sidelines. I'm going to use one eye to do the lot rather than separate eyes, and you've got 3 eyes around it, just trying to cut down and minimise on cost really, and this is perfectly adequate just to use the one in the top. The next we've got here is I've got a salvaged green, I believe this is a 6, it's a type 6 ferrite material, which is a high frequency toroidal core. Pulled this, and obviously out of an old power supply unit, was obviously used as the choke filters to filter out noise, common noise, white noise, and so on and so forth, which was present, with the switch mode power supply. So what we've done here is we've salvaged this, taken all the copper windings that were on it off very carefully, and we're going to be winding our 1-to-1 RF choke onto this, and the winding as we're going to use in reference to this is going to be it's where you've got 7 on one side and it crosses over and you've got 7 on the other, which is usually referred to as in a transformer layout as a 7 squared, giving you 49-to-1. But this is going to be a straight through current type balun, where 2 wires are just going to be wrapped around 7 turns here, 7th being the one that goes across to the other side, and then another 7 turns on this side here, making a good balanced RF choke in the centre of our centre fed half wave dipole. So that's what we've got there. Obviously we have the copper wire that is to be used on that, and there's some calculations and there's some little mathematics that we've got to deal with, so we can calculate the length, how much copper wire we actually need for the amount of turns and the distance covered with this toroid. So we have to measure it and do a few calculations. Very simple mathematics. The next thing we've got is the terminals. Now I'm going to be using the type of terminals that are bound together. So they've got their own little plastic support or sort of plastic spacer, shall we say, like this, and obviously they're held equally apart, with this bridge. There's the opposite side here, which is the black side, which goes either side of the things. Now with this, what we're going to do is this is going to come out of the back of the unit. So instead of having terminals on the side or whatever, we're going to have them on the back, so that therefore they feed out the back, out the back of the box sort of like that. That's generally the ideal layout. The SO239 is going to come into the bottom. At the moment I haven't got the SO239 in the box, it's in my little electrical carousels. But obviously we have two stainless washers, a stainless nylock nut, because we don't want the eye bolt coming loose out of the hole of the box and falling to bits. Obviously with these, they sandwich between. Now the thing is with these ones is to keep the clearance so that the terminals, the gold plated post terminals, don't come into contact with the aluminium case. The holes that have to be drilled are actually going to be much larger than the pin, and in this case these small tiny, if you can see, round circle type indentation from the plastic piece here, hopefully the camera will pick that up, try and get some angle all the way around on that, but there's little tiny raised indentations and recess, and this is that sits perfectly into a 13mm hole. 12.5 would be too tight for these, because that's exactly what it is. So a 13mm hole would provide a perfect clearance for these plastic, and they're on both the red and the black, and they're going to align. What we're going to do is mark it so that they align in the 13mm holes and sandwich between the case, which, as you can see, provides the perfect insulation that's required for the terminal post conductor to not come in contact with the aluminium case. Obviously these are assembled fairly simply. With these ones you've got a recess there. You can either have the terminal wire feed through hole that's in there, you can either have that facing that way or that way, and they're done by the little triangular cross-shaped indentations in there where these sit, and that holds it firmly like that. We obviously want it to come out that way, so we're going to probably align those in there so that the terminals go in that way and then can come up to the support lines. Obviously we've got also with the kit, it came with two gold plated washers, which are handy. Helps with, you know, corrosion out in the elements. You also came with 4 gold plated nuts, which obviously run onto there, and then obviously you've got the other nuts if you wanted to use little soldering terminals, and then they can be sandwiched between it. The little soldering terminals were not included in the bag when I bought these terminal posts, unfortunately. But it doesn't necessarily matter, because what I'm going to do is I'm going to, again, because these are gold plated or whatever, it's going to be very easy to actually solder directly onto the end of the actual terminal posts there. And then that's going to make our terminal post output. Obviously we have the screws for the top. I've got 4. See, I use these 3.5mm. Now you can buy these from your hardware store or any screw fix as we have in the UK, or Toolstation, etc. These are M3.5 electrical Sparkies screws. These are the things that you use to screw the UK sockets and light switches for the electrical installation in your home. These are made from nickel plated solid brass, which are perfect conductors. The nickel plated stops the brass from corroding, and the centre, obviously being brass, is actually a good conductor. It's the next best conductor effectively to copper, you know, that's obviously solid enough. Of course you've got silver and gold, which are good conductors, but you're not going to get solid silver and solid gold screws. So these are your best options. Now these aren't particularly cheap, but you can buy a box of 50 of these for about £4 in the UK. You don't need 50 for this project, but you know, they're always good to have. Obviously these, very easy to find the M3.5 taps for these, so you can cut thread into the aluminium case, which is what we're going to do. I'm going to obviously drill the holes for the SO239, and then I'm going to thread those 4 holes with to be able to take the M3.5s, and they're going to go into there. Now, as a ground connection, what I do is I open up one of the holes so that it's either 3.5 or 4 millimeters, and then I use another screw which is brass, into a brass nut, and then solder onto the brass nut. But again, because these are nickel plated brass, you can solder onto these as well. It's just the problem is that you have to get them pretty damn hot to get the solder to stick to them, which can be a challenge if you haven't got a good enough, you know, soldering iron or anything like that. But it is doable. It can be done. So that's pretty much basically the entire kit. Obviously, tools that are going to be required. You're going to need a drill. Obviously, you have to start with a small drill. You don't want to be hitting him with the big drill straight off. So all your holes, because we're talking 13mm for this size here, this is obviously an M8. So we've either got to do an 8mm, which is a perfect fit, which might be a bit tight, or an 8.5 hole to provide the clearance for the M8 thread. But you want to start with a small drill first. This I've got in here, this is actually a 4mm. Perfectly okay to use as a pilot hole, and then obviously you move up to a bigger drill, which I've got. This is an SDS, but I've got a chuck conversion which slots in to the end and converts me so I can use a normal drill here. And this is going to be drilling our 13mm holes. Our bigger drills are going to go in here. I also have a blacksmith's drill bit here. This here is a 14mm, and this 14mm is the one that's going to be drilling out the hole for the SO239 connector, which is going to be into the bottom of the box. We also have our 8mm drill bit here. This is an 8mm. I have got an 8.5, but it's somewhere around. I mean, this drill bit's seen better days. It's definitely a bit shot, so you know, I may have to source out a new drill bit from my, you know, tool kit. But yes, so there's that. Obviously, the normal tools, screwdriver, etc. Soldering iron obviously is necessity in this, because you need to solder. And that's it. The next level of jobs here is the wire that I'm going to be using. This here is stranded speaker wire, and obviously what I'm going to do is I'm going to split the figure of 8 speaker wire in half. So I've only got one conductor, one quarter conductor. That's all I need. And I'm going to be doing that now on the dipole. I'm going to be doing, it's going to be approximately 20 meters. Well, no, sorry, it's going to be 40 meters. So I'm going to need approximately 20 meters either side. It's actually about 22 meters, 21 point something or other. So if I cut about 23 meters, and then I've got enough to do the tuning and whatever, which is probably more than enough. It's always easier to have it longer and take it off than it is to have it short and put it back on. So that's always the good rule of thumb. So that's what we're going to do here. This was dirt cheap. This only cost me £9, and there's 100 meters here. So effectively, the 2 figure of 8s here, that gives you 200 meters of a single, stranded speaker cable. But obviously, turned into a single core or stranded core, you've got 200 meters then. So, and for £9, 200 meters of cable, that's a bargain at the best of times as far as I'm concerned. So So that's what we're going to be using, and obviously because this is quite thin, that's why we're going to be needing the support for it. So this is going to run from the eye bolt at the top, and this is going to run, this is going to be periodically attached to the guy wire, you know, and there's no strain or pressure that's going to be placed on the core of speaker wire effectively. So that's what it is. We've got the components. Join me in my next video and we shall get started in actually building this magic device. Okay.